Hey GED students, it's GED question of the daytime, and we're continuing our little explanation or exploration, I should say, of place value, because it's recently become apparent to me that even though a lot of students have memorized the different names for the different place values, they have no idea what it means. What they have memorized has no meaning attached to it, and therefore they're still getting a lot of place value type problems wrong. These show up on the GED, but also more likely, this concept is keeping you from understanding a lot of other concepts, mental math problems you can do, scientific notation. So let's go ahead and take a look. It says the digit 3 in the number 342 is worth how many times more than the digit 3 in the number 4.073, or another way to read that number, 4 and 73 thousandths. So that being said, both of these numbers have a number 3. And when I was asking students online about this question, these types of questions, they were able to tell me, well, look, that first 3 is in the hundreds place. So obviously that first 3 is worth 300. Okay. And they were able to tell me, well, this 3 is in the, and they started from the decimal place and said tenths, hundredths, thousandths place. Now, they were able, even though many of them were able to say thousandths place, they weren't able to tell me what that looked like numerically. So we'll just look at a 3 in the thousandths place. Looks like this. So there's 3 thousandths. So 300s compared to 3,000s, 3,000ths, sorry. How many times more is 300 than 3,000ths? And you might say, Kate, I have no idea. You actually do. We have what's known as a base 10 number system. Means a lot of things. That means a lot of things. One of the things it means is that we have exactly 10 digits. The digits 0 through 9 are what we use to build our number system. And there's 10 of them. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 digits. But it also means because we have this place value system based on powers of 10, you hear me say it, tens, hundreds, thousands, 10,000s. Each time I move a decimal place, the value of that place goes up 10 times. Let me say that again. Each time I move a decimal place, the value of that place goes up 10 times. So it's 10 times per decimal place movement. So let's take a look. Let us try to turn the number 0.003 or 3,000ths into the number 300 by moving the decimal place. So I'll have to move it 1, 2, 3 times. Right now, I just brought the decimal to the back of the number. I'm at 3 ones. I got to keep going to make it hundreds. I'll jump again. Put a 0 there, and jump again, put a 0 there. So how many decimal jumps did I have to get to turn 3,000ths into 300s? 1, 2, 3, 4, 5 jumps. 5 jumps. That's like 5 tens. That's like timesing the value by 10 5 times. 10 times 10, and it's so easy to multiply by 10. Every time you multiply by 10, you get another 0 on the backside. So, when I had 10 times 10, I had 100. Another 10 gives me another 0. Another 10 gives me another 0. Another 10 gives me another 0. I just figured out that the digit 3 in the number 342 is worth 100,000 times more than the digit 3 in the number 4 and 73 thousandths. 100,000 times more. That's a much more valuable 3. Great. If you have any questions about this or any other GED math concept, be sure to drop it in the comments and I'll do my very best to answer it.